I would like to share with you today is a summary of a project that Michael, Mariana, and myself recently completed, combining our various skill sets on a topic of common interest, which is geosocial marginalization. Gotcha. Okay. So just some background and some motivations for this project. So cannabis is probably the most heavily regulated agricultural crop in California in terms of its environmental impact, for several reasons, which I won't necessarily get into right here. But it's also one of the most geographically restricted agricultural crops in the state, based on this option that counties and municipalities have to ban licensed cannabis cultivation, which we spoke about earlier today. And so our work for this project is exploring some of the social, political, and economic factors sort of shaping the spatial distribution of licensed cannabis, and the sort of resulting interaction between the geography of licensed cannabis and the environment. Next slide, please. And so since this geosocial marginalization is going to be a term that we'll be using repeatedly in this presentation, I thought I would start by defining what we're talking about here. And so by this, we're referring to how margins, of lands and societies are comprised through and interwoven through biophysical land use and social processes. And the case of cannabis marginalization through legalization sort of illuminates three dynamics of geosocial marginalization here. And so the first being biophysical marginalization, in which uses and users are directed toward non-prime lands with sort of sensitive ecologies, inferior soils, geology, slopes, access to water, etc. The second being socioeconomic marginalization, or the ways that users are relegated to lands that can only really assume economically or socially marginal purposes. And then the third being sociopolitical marginalization, or the social and political subordination of certain uses and users to others, such as growing cannabis versus other agricultural products. And we'd like to also note that, instead of discrete categorizations of these definitions, these dynamics are sort of non-exclusive and sort of often overlap and articulate with one another. Next slide, please. So we laid out these three research questions. The first one being, what are the factors that contribute to the geographic distribution of licensed cannabis farming in California? The second one being, how does cannabis compare with other forms of agriculture, based on these metrics of potential environmental impacts? So we've heard, all sorts of things about the environmental impacts of unlicensed farming, and that narrative sort of bleeds over into licensed cannabis production as well. So taking a look at that as well. And then finally, how do these social and political economic factors play out? How do they contribute to the geographic distribution, and the land features of licensed cannabis agriculture? Thank you. And so our approach here was a mix of quantitative and qualitative methods. The quantitative analyses we were using to sort of try to identify these broad statewide patterns using spatial data, and then sort of apply some qualitative analyses, interviews, and whatnot, to explore the sort of underlying mechanisms, sort of going to the people who are actually on the ground, participating in this, to get answers to sort of explain some of the broad statewide patterns we're seeing. And so this is a figure or a map that is quite popular tonight, I guess. But I put this here just to illustrate that, California is a patchwork of county and municipal bans, and there's a lot of exceptions. So there's zoomed in picture here on the right is sort of a figure showing that within these counties there are municipalities that will allow cultivation. And so when we're trying to model this, we chose instead to focus at the county level and use the number of DCC cannabis licenses in a county across all of California's 58 counties, the number of licenses in a county as a measure of the amount of licensed cannabis farming and in the county. And so we considered several variables here. These six here I have kind of categorized. The first two being whether or not the county has a cultivation ban in the unincorporated areas, because there's still going to be exceptions. And then also whether or not the cannabis had an existing regulatory program prior to the 2018 launch of statewide licensing. So this is, the water board, and I think CDFW maybe, but I know the water board and certain counties had cannabis regulatory programs that were in place as early as like 2015. And then so the second set of variables here, the purple ones here on the screen, so we're sort of intended to reflect these the socioeconomic picture of each county, whereas the third pair of variables here in green were intended to capture socio-political factors. And so we have median income and proportion of retirement age as sort of socio-economic factors. The retirement age we set at 65. So the proportion of the county's population that's over 60 or 65 or older. And then the other two, the proportion conservative was just the proportion of registered voters that identified as Republican, and proportion farm employment is, of all the jobs in the county, how many of them are on farm jobs. And so this is sort of like a proxy for the presence of what we're referred to as traditional agriculture in each county. Next slide, please. And so the second part of the quantitative analysis was to look at these what we call potential environmental impact metrics, and then sort of ask like how the spatial distribution of cannabis, relative to other crops, what the comparison looks like. So we compared cannabis to three other crop categories. One is just general all crops. I should start by saying pasture, vineyards, or all other crops besides cannabis, pasture, and vineyards. And we decided to isolate pasture and vineyards because those are the other two that are kind of often regarded as more remote forms of agriculture, or I should say operating in remote areas. And so these three environmental impact metrics we chose were average terrain slope. So this is something that's associated with potential for erosion and runoff, both for the cultivation site itself and then also any sort of infrastructure that's needed to access the site, roads specifically. And then presence of watercourse, because if you have a watercourse on site, this is allowing direct access to surface flows, and increasing the potential for impacts to water quality and water quantity too, for that matter. And then finally, the presence of an underlying groundwater basin. And I should note, if I hadn't said this already, so we modeled this for locations of something like 2,500 cannabis farms, hay farms or pasture, vineyards, and then these other crops. So these are models based on the locations of individual farms. Okay, that being said, the third factor was whether or not these farms had an underlying groundwater basin, and that being a positive thing because it ensures reliable access to irrigation water without needing to rely on surface water storage during some of the driest periods of the year when stream flow is most vulnerable. Excuse me, vulnerable. Okay, next page or slide, please. And so just real briefly, the analysis of the county to county basis and the predictors of the number of cannabis cultivation licenses. There were two that were statistically reliable. The first one being on-farm employment. So counties in which there was a larger proportion of jobs on farm tended to issue fewer cannabis licenses. And the second one being median income. And counties with higher median incomes also issued fewer cannabis licenses. Thank you. And then as far as like these environmental impact metrics, when we compared cannabis to these other crop types, there was a pretty distinct difference in average slope. First of all, as you can see here, just the raw data, cannabis farms, the average slope of cannabis farms was something around 13%, whereas other farm types it's below 2%. These grayed out numbers you see here are the result of the model estimates from the models themselves, which we actually like accounted for spatial autocorrelation. But for the purposes here, just to describe the results, we can just look at the black numbers. The percentage of farms of each type that had a watercourse on site, I mean, cannabis is well over half, and nobody else even approached a quarter of the farms having a watercourse on site. And then finally, the number of cannabis farms that are actually in a groundwater basin are substantially smaller than any other type of agriculture. So I believe that's the end of the quantitative results. And so with that, I'll pass it over to you, Margiana, to fold the two together.
Great. So I'm really quickly going to mention three of the qualitative results, which we found were especially important in influencing where cannabis cultivation occurs. So the first one is competing agricultural land uses. A lot of the prime agricultural land in California is already taken. It's already being used to farm. And farmers who grow other crops and raise livestock have access to a lot of federal and state programs to help them do that. Technical assistance, funding programs through the USDA to help buy land, to have crop insurance, et cetera. And then another big issue is that some agricultural uses are really in direct conflict with cannabis. For example, vineyards, which we looked at, use a lot of pesticides. And so that pesticide can drift onto cannabis and make cannabis farmers' crops, test too high for those pesticides and not be able to be sold. Another big concern was over natural resources and environmental effects. And here, an important piece of our qualitative work was understanding the historical context here. It's not an accident that cannabis has primarily been cited in these remote areas, far from governing centers, far from enforcement. And that means often on steep slopes, on places that had access to surface water. But what that means today is that cultivators often face this heavy burden of compliance and a lot of environmental controversies because of where they have historically been cited. And then the third factor that we found was really important was the presence of anti-cannabis sort of political movements, especially often older, retired, and politically conservative voters, especially natural amenity consumers. So these are folks who buy land often in rural areas for the aesthetic value, for the ability to be in nature and engage in activities like fishing and hiking. Who tend to find cannabis to be aesthetically objectionable and unwelcome and not really fitting into a rural imaginary of a rural life that excludes drugs and the threats of urban racial taint that they carry. And so here to conclude, I know we're short on time, so I'm just going to say that the regulation of cannabis to these kind of marginal lands under prohibition and legalization is not an ahistoric accident. So I'm really going to emphasize that point. Rather, the uses and users of cannabis-related marginal lands are products of these social processes that create particular geographies, that incite particular kinds of conflicts, and generate new processes of marginalization. So this is that dynamic of pushing cultivators onto marginal land where it's harder for them to comply with environmental standards. And so we see this kind of cycle of marginalization. And these marginalities are primarily the product of historical and ongoing policy regimes, not the environmental or social deviance of individual actors or individual farmers, which they often are framed as in public debates.